In our previous sections, when we talked about congruence of polygons, each side had to have a corresponding congruent side in the other polygon, and each angle had to have a corresponding congruent angle also in the other polygon. With triangles, we can cut down the amount of information. If we had to compare all of that, that would be 3 sides and 3 angles for a total of 6 pieces of information. Our first congruence theorem that we're going to use for triangles is called the side-angle-side congruence theorem. Now, that tells us that if I know a side, an angle, and a second side are congruent to each other, as in this picture, a side, an angle, and a second side are congruent to each other, then I know that these two triangles are congruent without knowing the rest of the information. That cuts down the amount of work that we need. So we're going to use this theorem, and we're going to come up with 2 more in the next couple of sections. All right, now there is one extremely essential thing to know. It's that this angle right here is in between the 2 sides. The way that this is worded, it is absolutely essential that that angle is the included angle. That's why we talked about it in the last video. So you can see that this angle right here is the included angle between these 2 sides. So we'll pay attention to that in our next examples, where we're going to see if we have enough information to tell if 2 triangles are congruent. So let's take a look at these 2 triangles right here. We have a side right here, a second side right there, and an angle. These are both 90-degree angles, so they are congruent to each other. So we have a side, we have an angle, and we have a second side that we know are congruent. Side, angle, side. The last thing that we have to check is that this angle is in between those 2 sides, where it's the included angle, and it indeed is. So these 2 sides create that angle. So by the side-angle-side congruence theorem, yes, we have enough information to tell that those 2 are congruent. Now it's going to get long to write this over and over again, so you'll commonly see side-angle-side abbreviated with an S, an A, and an S. So the side-angle-side congruence theorem. Let's take a look at this next one. And you'll notice that these 2, the next 2 examples that we have, look very similar. The difference is the location of the angle, and that's going to make a big difference for these 2. You can see that this is in the corner right here, and this one is in a different corner right there. All right, so we have one side that's given that's congruent. You'll often see this setup where we have 2 triangles that share a side. If I were to split those 2 triangles apart, like so, I know that these 2 sides are congruent because they're shown right there, and these 2 sides really are the same side because it's that same line right there. So we have a second side that is congruent to each other. So I'm going to show that right here. We have now a side, an angle, and a side for each of those 2 triangles. A side, an angle, and a side. Are they in the right order? Well, these 2 sides create that angle, so it is in between. It is the included angle. So this one, yes, we have enough information again. This one, however, is a little different. We have that side, but when I take a look at these 2 triangles, the information is not in the correct order. So we have a pair of sides right here. We have a second pair of sides right there because they're really the same side. And we have an angle right here and here. And you will notice that the included angle is in this corner. It is not the one we know. So we don't know the correct side right here. We have a side and a side. This angle is not in between those 2 sides. So no, we do not have enough information on this one. So pay careful attention to where that angle is located. Let's take a look at our next one. Our task is to prove that these 2 triangles are congruent. We have triangle PQT and we have triangle RST. So PQT is that triangle and RST is that triangle. So the one on the top and the one on the bottom. And we have a pair of sides and a second pair of sides, but we don't have any angles that are given, so I'm going to go back to the vertical angle concept that we talked about. Vertical angles are created by intersecting 2 straight lines, and those vertical angles are congruent to each other. So we can see that situation happening right here. So we have this angle and this angle that are congruent because they are vertical angles. We now have enough information. We have a side, we have a side, and that angle is the included angle. It's between those two sides. So we have enough information. And we can say by the side angle side congruence theorem, these two triangles are congruent because we have a congruent side here, a congruent side here, and we would need to make the statement that these two angles are congruent. PTQ, angle PTQ is congruent to angle RTS because they are vertical angles. And then we say triangle PTQ is congruent to triangle RST by side angle side. So we now have enough information on that. Let's take a look at our last example right here. Our task is to name two triangles that are congruent. We can see these two triangles right here. And we are given that R is the center of this circle. Now that's important information because we need some congruent sides. If R is the center of the circle and we have some line segments going from the center to the edge of the circle, those line segments are all going to be congruent to each other. So we have this line, RS, line segment, and RT and RU are all congruent to each other because they go from the center of the circle to the edge of the circle. All right, that gives us enough information. We have a pair of sides, an angle, and a second side that are congruent to each other. So we can say that RST and RUT are congruent to each other by the side angle side congruence theorem. Thank you.